Hello guys, we have to find the eigenvector and eigenvalues of this matrix. So for the eigenvalues, we have to find the values first before the vector. For the eigenvalues is A, our matrix A minus lambda I equals to 0. This I is a unit matrix. So and our A is the matrix given to us. So we have the matrix we have is 1, 1, 4, 1 minus lambda. A unit matrix is an identity matrix, 2 by 2 identity matrix. Not just 2 by 2, but because our matrix is 2 by 2, that's why we also need a unit matrix of 2 by 2. So here we have 1, 1, 4, 1 minus lambda times 1, lambda times 0 is 0, lambda times 0 is 0, lambda times 1, lambda. Are we together? So sorry, we have to find the determinant rather. The eigenvalue equals to the determinant of this, the determinant. So we have to find the determinant here. 1 times 1, we have 1 minus 1 times 4, we have 4 minus. Let's subtract first. Let's subtract. So we have 1 minus lambda, 1 minus 0, 4 minus 0, 1 minus lambda. You know what you are doing is the determinant of A minus lambda. Oh, sorry, 1 minus 0 is 1 right? 1 minus lambda, 1 minus 0, 4 minus 0, 1 minus lambda. Now let's find the determinant. We have done A minus lambda I, this minus this. So now let's find the determinant. So the determinant now would be we have this multiplied by this. So here we have 1 minus lambda multiplied by 1 minus lambda minus 1 times 4, which is 4. Don't forget, it's going to be equal to 0. So here we have 1 times 1, we have 1. 1 times minus lambda, we have minus lambda. This also gives us minus lambda. This times this we have plus lambda square minus 4 equals to 0. So here we have lambda square minus 2 lambda minus 3 equals to what? Equals to 0. It will be minus 3 like that. Yeah. Equals to 0. So let's solve using quadratic equation. Can we factorize this? That should be, yeah, we can. So this guy gives us lambda square minus 3 lambda plus lambda minus 3 equals to 0. So we have lambda into lambda minus 3 plus 1, lambda minus 3 equals to 0. So here we have lambda minus 3 equals to 0, lambda plus 1 equals to 0. So we have lambda equals to 3 or lambda equals to what? Minus 1. So these are our eigenvalues. Now I want to find the eigenvectors. Now let's find the eigenvectors. The eigenvectors is our eigenvectors equals to, just like same thing we did, our determinant of what A minus lambda I multiplied by V but equals to 0. But this time we are multiplying it by V equals to 0. But we've done this guy already, which is this guy. Sorry. For the vector, it's not determinant. For the eigenvector, it's not determinant. It's A minus lambda I times V. And don't forget, initially we've gotten our A minus lambda I to be what? 1 minus lambda. Can back the video and see 4, 1 and 1 minus lambda. We got this earlier. So we are not finding determinant at all for our eigenvectors. The determinant is needed when to find our value. So here now, we are going to test, our lambda now multiplied by V. Our lambda equals to 3 or minus 1. So let's test for 3. If lambda is 3 here, this matrix will become minus 2, 1, 4, and what? Minus 2. Is that clear? Multiply by V. So what we are going to do now, because this is a 2 by 2 matrix, we are going to add a row of 2, like 2 rows to the front. We have minus 2, 1, 4, minus 2. Then let's say C1 and C2 equals to 0. So what we are going to do next is let me check. This multiply by this. So because this is 2 by 2 matrix, that's how our V will be in form of C1 and C2. If it is 3 by 3, we have C1, C2, C3. So all together equals to what is 0. Now using matrix method, for matrix we have this times this plus this times this. So this will be minus 2 times 1 minus 2C1 plus 1 times C2, C2 equals to 0. That's the first equation. This times this plus this times this. 4C1 this times this plus because there is minus here, minus 2C2 equals to 0. Now if we should do this now, that means here we'll be having C2. This guy will give us C2 equals to 2C1, right? Same thing will also happen here. I think we still have the same thing. This is 4C1 equals to 2C2. This one is 4C1 equals to 2C2. So if we divide by 2, we still have C2 equals to 2C1, which is still the same thing. Now, by testing for lambda equals 3, we have C2 to be 2C1. Now, let's also test for now. So which means we can write this guy as this our C1 and C2. We can write it as so this will represent our vector, like this C1 and C2 represent our vector. So here we have our C2 now. Here this one is C1. And what's our C2? Our C2 is 2C1. So these are vectors. What's their ratio? 1 to 2. Are we together? So these are our Eigen vector now for testing for lambda equals 3. 1 and 2. That's for our Eigen vector. When we are testing for lambda equals 3. Don't forget, these are our Eigen values. Whereby I find the determinant of A minus lambda I. This is not to get our value. Now to get our vector, you are not looking for determinant. You just find A minus lambda I times your A. And this one will be written, you have your form of like just a row of 2 by 2 matrix. A row of 2 by 2 matrix. If it is 3 by 3, you have a row of 3 here. So this is your first vector. Now let's test for minus 1. If you test for minus 1, no, we have 1 minus lambda. So 1 minus 1, here we have 2, 0, 4, 2. Multiply by b equals to 0. So here we have 2, 0, 4, 2. So we write this in, we have our C1 and C2 equals to 0. So we have 2 times C1, 2C1. Or we should use another alphabet instead of C. Let's use A. So this one gives us 2A1 plus 0 times this is 0A2 equals to 0. 4 times A1, 4A1 plus 2A2 equals to 0. So this one will give us, we have 2A1. This one is, we have 2A1 equals to 0A2. So for this one we have something like 4A1 equals to minus 2A2. So if you divide both sides by 2, that means 2A1 equals to minus A2. Because this guy is 0, so we don't need that first part because we have a 0 here. So we are not dealing with that one. So here is equals to 0. So we are making use of this guy that we have value for. So we have 2A1 equals to minus A2. So we can say minus A2 equals to what? 2A1. So if you want to write it in form of this, let's say A1 and our A2. So don't forget our A1 is this and our A2 is 2A1. If you multiply 2 by minus, that means A2 will give us minus 2A1. So here we'll be having minus 2A1 instead of our A2. So the ratio now will now be 1, minus 2. So for the first one, when testing for value 3, we have 1 and 2 for our vector. When testing for minus 1, we have 1 and minus 2. And that's all about Eigen values and Eigen vectors. Don't forget to like.